Question 1.3e for extension is solving absolute value equations. An absolute value equation is an equation that contains absolute value expression. So here are a few examples. The absolute value of x equals 2. The absolute value of x plus 1 equals 5. 3 times the absolute value of the quantity x plus 5 equals 15. So let's talk about absolute value first. Absolute value is the distance from 0. And because it's distance, we know that the answer always has to be positive. You cannot have a negative distance. So if I were finding the absolute value of x, I have two options. And what are those two options? Well, let's take a look to the right here for a second. What is the absolute value of positive 5? Well, it is 5 units away from 0. The same question is, what is the absolute value of negative 5? Well, negative 5 is 5 units away from 0. So that means two situations occur where we can get positive 5 as an answer. So when we solve an equation with variables and absolute value, we have two situations that can occur. The number inside the brackets can be positive or it could be negative. What do I mean? Well, let's try a first example. Solve the absolute value of x minus 4 equals 6 and graph the solutions. Okay, so I have the absolute value of x minus 4 equals 6. Well, the absolute value of whatever is inside the brackets, that expression can equal positive 6 or that expression can equal negative 6. Remember, because even if we got negative 6 in here, it would still equal a positive 6 because of the absolute value. So you're going to set up two situations and you're going to solve them both. And you're going to solve them the same way. X minus 4 equals 6. I'm going to add 4 to both sides. And I'm left with x equals 10. Or add 4 to both sides. Add 4 to both sides, x equals negative 2. So let's go back in and substitute our solutions and see if we did it right. If I have x minus 4 equals 6, but it's the absolute value, I'm going to plug in 10 and negative 2. So 10 minus 4, does that equal 6? And negative 2 minus 4, does that equal 6? But again, look, Ms. Abruzzi already forgot. Don't forget the absolute value brackets. Well, 10 minus 4 is 6. And what is the absolute value of 6? 6. So that is the solution. Negative 2 minus 4 is negative 6. And what is the absolute value of that? Positive 6. So we did it correctly. So it's going to have two solutions. And you can graph the solutions on a number line. You'll have negative 2, 0, 1, 2, 3, 4, all the way up to 10. X equals negative 2, and x equals positive 10. And let's try the next one. Solve the absolute value of 3x plus 1 equals negative 5. So I'm going to take my equation, but let's pay attention to this one. This is saying that whatever is inside the brackets, the absolute value of that will equal negative 5. Can I ever get negative 5 as a solution for absolute value? The answer is no. So this is a no solution problem. Example number 3. I have the absolute value of 3x plus 9 minus 10 equals negative 4. So this one is a little bit different. Even though it is equal to a negative, and I kind of want to go in the no direction, the no solution direction, I can't just yet because I need to eliminate this negative 10. And I'm going to do that by adding 10 to both sides because I want to isolate the variable, but I need to isolate the absolute value brackets first. So now, why didn't you draw? Oh. So now I'm left with 3x plus 9, the absolute value of that, equals negative 4 plus 10 is 6. So look here, now I'm back to a positive value, which is what I want. So just be careful whenever you see it equals and negative. Don't just throw no solution out as soon as you see it. You might have to do a little bit of work. So again, this problem is absolute value. It could equal 3x plus 9 could equal negative 6, or 3x plus 9 could equal positive 6. There's two situations that will be true. So you're going to solve the equations the same way. Minus 9, 3x equals negative 3. Divide by 3, x equals negative 1. Or solve the second equation the same exact way, minus 9 from both sides. I'm left with 3x equals negative 6, and negative 9 is negative 15. Divide by your coefficient, x equals negative 5. Both are solutions to this one equation. And the last example is 4 times the absolute value of 2x plus 7 is equal to 16. So again, just like the last one, we want to eliminate any numbers that are around the absolute value expression before we start setting up our two equations. So this 4 is joined here, just like if it was next to parentheses. It's joined by multiplication. So we're going to do the inverse, and we're going to divide both sides by 4. 4 divided by 4 is 1. So then I'm left with just my absolute value expression equals 16 divided by 4 is 4. So let's go ahead and set up our two situations. 2x plus 7 equals 4. 2x plus 7 equals negative 4. Let's solve these. Let's subtract 7 from both sides. 2x equals negative 3. Divide both sides by the coefficient of 2. X equals negative 3 halves. Same exact way on the second equation, minus 7 for both sides. Remember, 7 is your constant, the number that stands alone. Negative 7 and negative 4 is negative 11. Divide both sides by the coefficient of 2. X equals negative 11 halves. Now you could leave your answer as a fraction. You don't even have to go to a decimal. As long as it's a simplified fraction, leave it. This way you don't make any mistakes trying to change it into a decimal. Okay, so now try some examples on your own.